Welcome to the third section of this course, Operating Structural Patterns. And in the previous section, we have observed working with creational patterns and observed some of the important creational design patterns such as factory, abstract factory, and singleton. And in this section, we shall start with decorator pattern, understand what is decorator pattern, and then we shall implement decorator pattern. Once we understand decorator pattern, then we shall understand facade pattern and implement facade pattern using a real-time application. Structural design patterns are used to make the design easy by identifying a simple way to realize relationships between entities. And here we are at the first video of this section, decorator pattern. And in this video, we shall understand what is decorator pattern and what are the advantages of decorator pattern. And also, we shall understand a real-time scenario where we need to use decorator pattern. Now, let us start with understanding what is decorator pattern. In simple terms, to understand the decorator pattern, it allows behavior to be added to an individual object either statically or dynamically without affecting the behavior of other objects from the same class. The decorator pattern also follows the single responsibility principle, which means that every class should have responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class. Basically, this means that it should do one thing and it has to do well. Some important points we need to remember while working with decorator pattern is: you must construct a wrapper around an object by extending its behavior. This wrapper will do its job before, after, and delegate the call to the wrapped instance. And one more important point is that the constructor requires an instance of the component from the hierarchy, which enables it to build upon that and use composition rather than inheritance to override which individual feels that it wants to. Now let us understand a simple UML diagram for decorator pattern. The component class is typically an interface, although it can be an abstract class that has a concrete instance represented here in the concrete component of this diagram. The concrete component is what we are going to eventually decorate, and the decorator is the base decorator or wrapper that we will extend and create other decorators from. Now it should be of note that both the concrete component and the decorator extend the component so that they can be treated the same. From here we can create multiple concrete decorators to decorate our object and provide functionality as we develop. Decorator pattern can be used as an alternative to subclassing. Subclassing adds behavior at compile time, and the change affects all instances of the original class, where decorating can provide a new behavior at runtime for selective objects.